Good morning. So today we'll start chapter 11, which talks about the second layer, which is data link layer. So in chapter 3, 4, 5, we finished physical layer, which is the first layer. Then in chapter 11 and 12, we'll talk about a data link layer. So at the beginning, from our introduction, what is the main function of a data link layer? Hmm. So data link layer deals with point-to-point or node-to-node communication. But unlike the physical layer, it concerns about two main things, link control and medium control. So I need to control in the link while I'm transmitting through flow control, error control, and the framing and making addressing and all this stuff. And also medium control when we talk about multiple nodes share the same link. So how we can share the same link between multiple nodes. So the two main functions of data link layer are data link control or link control and medium access control. So I need to control the link and I need to control the medium. But still, we are still in this data link layer. We deal about node to node. Okay. So the first task is data link control. Deal with design of communications between two adjacent nodes. So we talk about node to node communication, not end to end, because I may have source here and destination here, and in the middle, مثلا, four routers. So data link control don't care about the source or destination, you just care about two adjacent node or two adjacent router and control the communication between the two adjacent nodes. Control communication from what perspective? From a link perspective, how can I transmit from this node successfully without error and without overwhelming the receiver? And also, if multiple nodes, if here another source, share the same link and go to another destination. So if these two sources share the same link, how I can divide this medium or divide this link between multiple nodes, okay? Which is medium access control. How we can share this link between multiple nodes. So in medium access control will be discussed in chapter 12, and in this chapter we will talk about data link control. Okay. So the main functions inside the data link control are framing, flow control, and error control. So these are the main three functions that discussed we'll discuss in this chapter. First, we'll start by framing, then we'll talk about different protocols that care about the flow control and the error control. Okay, so it is clear how the flow for data link control and access control and how the flow will proceed for chapter 11 and 12. Okay, so the first task in data link control is framing. So we need by framing is how we can collect from the application layer we will receive data. So how we can divide this data into frames and distinguish between the frames. So the arriving data, if I need to send مثلا one file with size 1 megabit per second or 1 megabyte. So how we can divide this 1 megabyte into multiple frames and distinguish between the different frames so the receiver can receive these frames correctly and decode these frames correctly. So in postal example, it's like we need to send a letter. So before we send the letter, we put it into an envelope. So the framing is the envelope of the data. So I receive the data from the application layer. I put this data inside a frame. Then send this frame to the physical layer. Okay. So the framing can be an envelope, and this is the letter or the main data inside the frame. Okay. Why we need framing? Can we send the whole message in one frame? That's it. If I need مثلا to send file 1 megabyte, can I send this file directly to the destination in one frame or without making frame? Just send this file. Yes, my this size I fix the size. For example, I will define the size of the frame مثلا uh, 80 مثلا bits. So I define this maximum size, but why I am defining this maximum size and I don't say we can send the whole data, whatever size of the data, I send the whole data in one frame. Why I need to divide this data into multiple frames? What will be the problem at destination? Mm. One of the reasons because at the end the data comes from the application, I put it in buffer before transmitting it. And also the receiver, at the receiver side, when I receive this data, I put it in another buffer before it go for processing. So this buffer size may have limited size. So I can't receive large frames, I have to receive smaller frames. This is one reason. The limitations at the receiver side, the capability of the receiver. Can the receiver or it can just deal with small frames for processing? Because this receiver can be a small device with small memory. So can receive a large file at the same time. So it needs to receive small file, receive another frame. This is one reason. The capability of the receiver. So what another reason? Hmm. The main reason we discussed every time. What about the channel? Is it acceptable from the channel point of view to send only one frame with the whole data? Or it's better for the channel to receive multiple frames? What's the problem in the channel? What's the problem in the channel always generates errors? So if I put all the data in one frame and only one bit from this frame decoded wrong, can I decode all the frame? Can I know what inside the frame? No. All the frame will be dropped from my example. Because some bits or some bytes has an error. But if I have short frames and one of them dropped, it's fine. I will receive this correctly and I will receive this correctly. Then I can deal with this one with error with مثلا transmit it again. But if I send all the data at the same time and I have an error, I will lose all the data. So instead of losing all the data, I can divide it into pieces or frames. Then whenever I have an error in one frame, I may receive the others correctly. So these are the two main reasons for the framing. Error control, I need to reduce the errors by sending multiple frames. And also flow control. I don't want to overwhelm the receiver or make the receiver not processing the data as fast as I want. So framing, we separate the message from one source destination and we divide it into frames. So we need to distinguish between these frames and also we need to define what is the source and what's the destination for each frame. So I put here MAC address of the source and the MAC address of the destination. So I can know this frame related to S1 مثلا D1 and the other frame related to S2 D2. So I need to differentiate between different sources by making address and also Even if these frames belongs to the same source and destination, I need to define this frame 1, this frame 2, this frame 3. So even for the same source and destination, I need to distinguish between different frames for the same source and destination. طب why I need numbering يعني why I need to define this frame 1, this frame 2, this frame 3, or S1, S and D1. يعني why I need to distinguish between the frames even if we have the same source and same destination. Exactly. Because some application I need to receive them in sequence. So I need to know the sequence. Also, if one of them has an error and I drop them, so I need to send for the sender the number of this frame so the sender can again to me. So I need to know the number of the frame even if it's related to the same source and destination. Okay? Any question? What about types of framing techniques that we can use? We have fixed size framing and variable size framing. So this is the first categorization. Fixed size framing and variable size framing. The fixed size framing, from its name, the frame size will be fixed. So all the size of the frame will be fixed. For example, if I said that the frame size will be 80 bit, خلاص, it's fixed. I will send each frame with 80 bit. So there is no need to define the boundary of the frame because I know it's a fixed 80 bit. So the receiver should know the start and the end of the frame. If we use fixed size framing, should I should I start here with مثلا one flag to let the receiver know this is the start and this is the end? No, because it's fixed size. So the receiver know each 80 bits will be of one frame. So I don't have to define the start and the end. It's fixed size. So the receiver will know I will receive stream of bits. I will divide them into 80, 80, 80, and each 80 bit will be one frame. So I don't have to define the boundary of the frame, the start and the end of the frame. But in the variable size framing, the second type, the frame size can be variable. So for example, I can send frame 1 with 80 bits, frame 2 with 85 bits, frame 3 with 90 bits, and so on. So I can change the size of the data inside the frame. Then the other fields should be fixed. Then address مثلا fixed size and so on. The other field usually it's fixed size. So I can vary the data size and I send frame with variable size instead of fixed size. But in this case, can I send it directly without defining the start and the end? No, and now it's variable size, so the receiver should know what is the start of the frame and what is the end of this frame. So I have to define the end of the frame and the beginning of the next frame. Okay? Right. To define the beginning and the end, and inside this variable frame, variable size framing, we have two types: characteristic oriented approach and bit oriented approach. So now we have fixed size and variable size, and inside the variable size we have characteristic oriented and bit oriented approach. Okay. So now about what's the difference between character oriented and bit oriented? It's very easy. The main difference between them is how we can deal with the bit. I can deal with the bit as characters or as a bit. Okay. So in character oriented control, we have variable number of characters and error and the flag to define the start and end of the frames. And inside the data will defined by characters and will have variable length. Okay, so I put flags to define the start and end of the frame, and header and tailor to define val I source address or IP will destination address and all this stuff. Okay, but in character oriented, I am dealing with characters. I define the data as a characters. Okay, now we have one problem. I will put flag to define the start and the end of the frame. Okay, for example, this flag will be a certain character. مثلا, for example, A. When I put A at the beginning and A at the end, so the receiver will know that this A or مثلا another code 0 مثلا 1110 and 0 111110. So once this our fixed flag, so the receiver when receives this flag, it knows that this is the start of the frame and this is the end of the frame. طب where is بقى the problem? What if this flag or is this مثلا sequence of bits by chance come inside the data itself? If the data itself contain by the chance 0410 and طبعا other bits here and other bits here, but by chance this flag appear inside the data. لا في الاخر the flag I define it may contain the data same code or the same sequence of bits. So the receiver now will be confusing. It will define this as a start, but it will consider this is the end of the frame. Why is this wrong? This is part of the data, not the end of the frame. You know the problem? I have to put flag to define the start and the end. This flags used because I am using variable size framing, so I have to put flags, and these flags can by chance come inside the data. By chance, I can have some data with the same pattern of this flag. So how we can solve this problem back if the flag of if the pattern of the bits I used to define the flag appear inside the data? I need to notify the receiver, take care this is part of the data, not the flag. So how can we make this? By byte stuffing. For character oriented framing, we use byte stuffing because character using divided by bytes, size of the character using in bytes. So I using what we name byte stuffing strategy. So what's this byte stuffing? When I found and this we have flag, we have the data, and we have another flag. If inside the data this flag appear, I will use byte stuffing. I will add certain character to notify the user, skip this flag. This is not a flag, skip this part. This is what we mean by byte stuffing. So byte stuffing is the processing of adding one extra byte whenever there is a flag inside the data to skip this flag. Okay. So once I found certain flag inside the data, I will put here skip one character to notify the user, لا, skip this part, don't consider it as a flag, continue, and receive this data and continue. Once you find the flag, you will stop here. But if you find the flag and before the flag we put a certain extra byte skip, you should remove this part. So, for example, here I receive the data from the pattern. And flag. What about the data? I will put extra and one byte if the skip inside the data, I will put before the skip another skip. So just tell user this is skip this part. This skip and then skip this part and continue. Because now I have flag with certain function. So I should tell the user this part of the data and not the flag of the start and the end of the frame. So I will put skip before the flag. And also skip character. If it's appeared inside the data, I will put another and transmit this as a transmitter and I can transmit this. So how many extra bytes I added here? Two. I added two extra bytes, two skips. One for the flag and one for the skip. And the receiver side to receive this data, it will this is a flag, okay, this is the start of the frame, I will continue. This skip, so I have to skip this part and continue. Another skip, so I have to skip this part and continue until I found the skip, the flag, so I have to stop here. And when I send the data to the upper layer, I will remove the extra skip flag and I will forward the data from the upper layer as a receiver side to the upper layer without the skip. Yes. We add frame size because, because here we're using variable frame size. All this, all this stuff under the variable frame size. Fixed frame size, plus we don't have all this problem. We'll not add a frame. لا ما this extra information يعني انت if you have مثلا 1000 frame each frame before the frame you will send size you will print size فthis يعني it's extra data you add to the information. This is one thing. Another thing, what if you receive an error with this frame size لان احنا at the end we will send the data at the channel, so maybe one of the frames is corrupted, or if you add this information to notify the user this is the size, this size can be corrupted. But in this case, all the decoding will be wrong. For example, if I send مثلا 3, I tell him 111, the size of the next frame is 3. And this received so I received 101. So خلاص so it's usually in the communication يعني automatic. We don't add too much manual things inside the process. So instead, we'll make it variable as it, but we define start, put a flag, we define this start, this is the end, and size would be whatever size we can include inside. And for the problem of the flags, we add skip. Okay? So this part can be okay. So the data section is stuffed. This is what we mean by byte stuffing. So you should know the definition of byte stuffing. Data section is stuffed with extra byte. This byte usually called escape character, and it's a predefined pattern that's used with a flag or with a skip inside the data. And whenever the receiver found this escape character, it remove it and continue with the data without this escape character, and not exit the frame. And it will continue and consider this as a part of the data and not exit the frame. Okay, so how can I ask you about this in the exam now? I'll give you this data. Generate the frame or the frame that will be transmitted. If we have this data, what will be the frame transmitted? Or another way, how many extra bytes I will add for this frame? Yes. For it now, I have this data, and by chance, I found some pattern, the pattern of the flag I received inside the data. So before each skip, I will put a skip and continue. I found a flag, I put a skip. Found skip, I will put skip. Found skip, I will put skip. I found skip, I will skip. And I found flag, I will skip. So I will have three skips and flags inside the data, so I have to add 3 extra bytes to define that is part of the data and not part of the start and or end of the frame. And this is what we mean by byte stuffing. I put extra bytes before flag and skip. Any question? Hmm. Okay. The other type is bit-oriented framing. So we still inside the variable frame size. We talked about character-oriented framing. Now we talk about bit-oriented framing. Bit-oriented framing, I will deal with the all things as a bits. So now I will fix a certain pattern of bits for the flag, which is 0, 6 ones, and 0. This is the pattern or the code for the flag. And the data will be defined by bits, but it will have variable number of bits. Okay? So now instead of dealing with the characters, we deal with the bits. Now, what will be the challenge again? If I have this, I found inside the data by chance, 0610 appear inside the data. So now we put bit stuffing process, not byte stuffing. It will be bit stuffing. So take care about the difference between byte stuffing and bit stuffing. Okay. So what's bit stuffing? We will add extra zero whenever 5 consecutive ones I found it. And now what's the problem? Now the flag is 0, 6, 1. So but if I found 5 ones, I have and if I leave the 6 ones, it will be same as the flag. So now when I found 5 ones in the data, I will add 0. So now what will be the sequence? 0, 5 ones, 0, 1, 0. Is the flag? No. So it will be considered as a part of the data. And the receiver. The receiver side will try 5 ones and 0 to remove this 0. And return the data as 0, 1, 1, 5, 1 and include also this 1 and 0 and calculation as the receiver side. What's the advantage بقى of this bit stuffing compared to byte stuffing? Hmm. What's the advantage? Here what I add as an extra 1 bit 0 when I found 5 ones. طب in the character oriented I'm adding 1 byte which is 8 bits. So which is more efficient? Bit stuffing is more efficient because I don't have to add much information. I just add 1 bit extra. And I don't, and from communication point of view, I don't need to add extra data as much as I can. I need to reduce the data as much as I can and reduce the bandwidth consumed. So I need to send all the data, the important data. I don't add more information unnecessary. So here in bit stuffing, I will add only 0 when I found 5 consecutive ones. Okay, so I will not have 0, 6 ones, 0 as the data at all. After bit stuffing, I will not have 0 and 6 ones. قصدك يكون الداتا اصلا من الاول جايه كده. اوكي، ما انا في الحاله اللي زي دي ما في حاله احط اساسيه لان الفايل حتى لو دي واحده حتى لو دي انا الرسيفر كده اوكي اوكي. فلاتس تيك ان اكزامبل بقى. ده يعني a little bit يعني more difficult لأن I will give you the data as a sequence of zeros and ones and I will ask you to generate the frame. So you itself will have to detect. You will find one, find ones and add zeros. And this will be the frame. And the receiver side will be I will remove the okay. And here when I give you the data, how many bits you will add for bit stuffing. Okay, is it clear? Any question? Okay. But this is the first function of the data link control. So as I started in data link layer, we have link control and medium control. In link control, we have three main functions: framing, error control, flow control. Now we finish the framing and the remaining part of chapter 11 will deal with flow control and error control protocols. Okay, how we can deal with the flow and how we can deal with the errors. What we mean by flow control, how we can send the data in a smooth way without overwhelming the receiver. Because the speed of the processing between the transmitter and the receiver may be different. Maybe a transmitter or source can process مثلا 1 megabit per second can process this data. But the receiver can مثلا process only half megabit per second. So if the transmitter process, transmit, it will overwhelm the receiver. What we mean by overwhelming, if you remember the buffer at the receiver side, start to process the data. So if the speed, here's the buffer, if the speed of the processing at the receiver side less than what will happen? I receive 2 bytes per second, but I am processing 1 byte per second. That fixed size. Size 10 bytes. So I receive 2 and put 1 and 1. Now I am processing 4 times. So I will process 10 bytes and I will put 10 bytes in the buffer. So in the next byte, in the next time, we will receive 22. I will process 1. So now it's 10. And 1, what about extra 1? I will drop it. Run that. Doesn't have space at the reservoir. This is what we mean by overflow. Overflow, and I don't have size for the account flow. All my buffer is full, so I will drop the account flow. So this is the flow. What we mean by I need to avoid overflow by implementing flow control. From the transmitter to avoid this overflow or overwhelming the receiver, to avoid missing the data the receiver receiving slow. So to avoid this problem, we need to have we should implement flow control. And error control is easy on the channel. If I received one frame with errors, so how can I deal with this error? So in data link, I need to deal with two main issues: flow control and error control. And this is we'll study five protocols for flow control and error control. Two for the noiseless channel, which is the ideal case. As we started always, we start by the ideal case, so we don't have any errors with the channel. So it's the simplest way, just to define the algorithm and the logic behind the flow control and error control for the ideal case. Then we will study three protocols for the practical case or noisy channel. This is the remaining of chapter 11 until the midterm, inshallah. Any questions?